This video is on classwork number 3, solving quadratics and literal equations. So whenever you have a quadratic, you always want to make sure it's set equal to 0. If it's factorable, I would factor it. This one is one that is factorable. So you can think of this one using a diamond. What multiplies to 10 and adds to 7, and that's going to be a 5 and a 2. So this answer is going to be x plus 5 times x plus 2. Equal 0, that's the factors. And then you're going to set each of the factors equal to 0. So x equal -5 and x equal -2. And those are your two answers. Now, the next problem looks very similar to that one, but there's nothing that multiplies to 12, a positive 12, and adds to 1. If this had been a negative 12 and a 1, that would have worked, but not a positive 12 and a 1. So this one, I'm going to use quadratic formula. And the formula is x equal -b plus or minus the square root of b squared minus 4ac all over 2a. So this is going to be x equal -1 plus or minus the square root of 1 squared minus 4 times 1 times 12, all over 2 times 1. So now I'm going to end up getting -1 plus or minus, and when I do 1 squared, I get 1. And I'm just going to put this in my calculator. So I'm going to do what's underneath the radical. So 1 squared is 1, so I'm going to have 1 minus 4 times 1 times 12. And I end up getting a -47. So I end up getting the square root of a -47 all over 2. And when I have a negative underneath the radical, that's an imaginary number, so it's going to have an I. So it's going to be -1 plus or minus I root 47 all over 2. Now you could look and see if you can simplify the radical, and you would want to do that, but 47 cannot be simplified. So that's your final answer. On this one here where you have just an x squared, what I would recommend, and no x, get everything, get the x squared on one side, everything else on the other side. So I'm going to be adding 9 to both sides. And I'm going to get 3x squared is equal to 15. I'm going to divide both sides by 3, and I get x squared is equal to 5. And then I'm going to take the square root, and anytime I take the square root, I get a positive and negative. So I get a plus minus root 5. And that's that answer. On D, we're going to complete the square. That's what they're asking us to do. I personally like to complete the square when I have an x squared with a lead coefficient of 1 and my x is even. So this is a good setup. Since I'm completing the square, I'm going to leave my -2 over here because it's not helping make this a complete square. So two ways to do this. One way is you can make a box. So you can use a box as one method, and I'll show you another method here in a second. So if you're making a box, right now I'm looking at this x squared plus 6x. So I'd have my x squared here. My x's go here. Since this is supposed to be a square, I need to split these evenly. So my 6x has to be split evenly as a 3x and a 3x. And this is going to have to be an x plus 3, an x plus 3, and then this piece right here is missing. That's where I need to complete my square. And because this is a 3 and a 3, that's going to multiply to 9. That's what it's missing. So that means I'm going to have x squared plus 6x plus 9. And I need to add 9 to the other side. If I do it to one side, I have to add it to the other side. So now the whole reason I did this was to make this into a complete square. So this is going to be x plus 3 squared. You can see that here. Here's my x plus 3 squared is equal to 7. And now I'm going to get x by itself, first I have to square root. So this is going to be x plus 3 equals, and again, every time I square root, plus minus root 7. And the very, very last step here is I'm going to get my x by itself by minusing the 3. So I'm going to have x is equal to, and I like to put the number here in front and then have my radical. Okay, so I was subtracting 3, so I'm going to go negative 3 plus or minus root 7. And that's my answer. Now, another way to think about this is basically what I'm going to do is I'm going to take my b, I divide it by 2, and then I square it. That's how I got this 9. So another way to do this, when I'm looking at this, I know it's x squared plus 6x, and I know I need to figure out what to make a complete square. So I look at my 6x and I go, okay, 6 divided by 2 squared. Okay, and 6 divided by 2 squared would be 3 squared, or 9. So I'm going to add 9 here, and I'm going to add 9 to the other side. And then I'm going to solve the rest of the way just like this. Now, here, sometimes it's a little harder for us to see the square, but whatever half of your b is, okay, and half of my b was 3, that's what's going to go here. And then I can solve, and I will end up getting that answer. Now, the next one is a literal equation. Make sure I got all of them. Yep. Is a literal equation. And what literal equation means is that you have more than one variable. So they're going to have to tell you what variable to solve for. So here they want us to solve for x. So first off, I want to get this term by itself. So I'm going to minus 2c from both sides. And I'm going to get negative 3x is equal to negative 3 minus 2c. Then I want to get x by itself, so I'm going to divide by negative 3. Now I can do one of two things. I can divide each of these separately by negative 3, or I can divide the whole thing by negative 3. So this would be negative 3 minus 2c over 3, over a negative 3. That's an acceptable answer. A lot of times in math, we don't like to have a negative on the bottom, so sometimes we'll end up taking the negative from the bottom and distributing it through the top. And so if I was to do that, it would actually end up becoming a positive 3 plus 2c over 3. And again, you could have divided everything by negative 3 separately. So I'm just showing you a couple ways you can write them. All of these are the same. So instead, when I had my negative 3 minus 2c right up here, instead of dividing the whole thing, I can do each separately. And then when I do that, you see I'm going to end up getting negative 3 over negative 3, which is 1. So here, this is where I would have had my 1. And then here, a negative over negative is a positive plus 2c over 3. What you do not want to do, these 3's cannot be canceled out, because here the 3 not only is dividing this 3, but also this 2c. So this is an acceptable answer. I'd also take this as an answer, or this. They're all the same. Now on letter F, I'm solving for A. So first thing I'm going to do is try to get my AK by itself. So I'm going to get rid of this B, which means I'm going to multiply both sides by B. So when I multiply this side by B, I get BU. And when I multiply this side by B, the B's are going to cancel out, and I get AK. And then I divide by A. Oops, I'm sorry, I'm solving for A. So I want to divide by K, because I'm solving for A. And I get A is equal to BU over K. And that's your answer. On G, I'm solving for X. Now you'll notice you have X's in more than one spot. So you want to get all the X's on the same side. So what I'm going to do is I'm going to minus X here, and I'm going to minus X here. So I'm going to have XM minus X equals Z. Now, when you have this here, and you'll notice you have x in both terms. I can factor the x out because it's in both terms. When I factor it from here, I get m, and this is where you have to be careful. When I factor it from here, I get a 1. I get a minus 1 is equal to z. I'm going to try to get my x by itself. It's multiplying with this now, so I'm going to divide by m minus 1 by m minus 1, and I'm left with x is equal to z over m minus 1, and that is your answer. Okay, and H. This one is not a literal equation. This is just order of operation. So you'll notice we have a lot of parentheses. An order of operation is PEMDAS. Please excuse my dear Aunt Sally. I do parentheses first, exponents, then multiplication from left to right, okay? Whichever one comes first. And then addition, subtraction from left to right, again, whichever one comes first. So the very first thing I'm going to do, let me just get a different color here. I'm going to do, you start with your innermost parentheses and work your way out. So I'm going to start with this piece right here, okay? Okay, so I'm going to have parenthesis, and when I do 9 minus a negative 6, that's actually going to become plus a positive 6. So that is going to end up being 15 divided by negative 5 plus 5. And I'm going to, instead of writing it like this, I'm going to put a bracket. That way I don't have too many parentheses going on. So 15 from here divided by negative 5 plus 5 times, and here I can do this 2 to the third, and 2 to the third is 8. So now inside I'm going to be doing division, okay? So 15 divided by negative 5 is negative 3. So now I have negative 3 plus 5 times 8. When I do negative 3 plus 5, I get 2 times 8. And so my answer is going to be 16.